Good morning. Well, I'm so sorry. It was so unexpected. So suddenly my laptop stopped working for some reason. And luckily, I pushed everything to GitHub. So I wanted to actually tell you at the end of my presentation to go to the GitHub and then check it out. Well, I didn't know that I have to check it out first. That's good. I tested and it's working. So let's just quickly talk about my presentation. Today I'm going to talk about progressive web apps. The tips that I'm going to tell you today, it's not just applied to Angular. You can use it everywhere in all applications that you are going to build with any other frameworks. So, but in particular today, I built some of the demos with Angular and I implemented those methods in Angular to show you how you can use it in Angular itself. So before I just start, a little bit about me. My name is Majid, and I'm coming from Oslo. I'm originally Iranian, and I'm not a real Viking, but I try to be a real Viking. You see my boots. So I'm very familiar for this weather. And you can find me on Twitter, LinkedIn, and GitHub with this handler. If you like me after this presentation, you can follow me. Today's talk is mostly about how we can progressively enhance user experience. One quick question. How many of you actually built a progressive web app and have it in production right now? OK. Well, building a progressive web app is a different story. Have it in a production and then enhance it is another story. I'm going to talk about after deployment, when you have your application in a real production, and how we can actually enhance user performance. So today's talk is mostly around this topic. So I'm going to talk about app banner prompt, but it's a different things after deployment to give our user better user experience. I'm going to talk about better app theme, background sync, and, well, advanced cache strategy in service workers, which is cool. We need to understand what is going on behind the scenes when we are talking about some terms. What does that mean? So let's talk about app banner. We all know that one of the features in progressive web app is that they are installable. So as soon as we pass all the requirements, our application or the browser will show some kind of banner to our user that they can install our application to home screen. However, sometimes we don't need to show that banner immediately. One disclaimer here that some of the things that I'm talking right now today, they are not implemented in all browsers. But we are always talking about progressively enhanced, right? So we implement it for those users that they have already this feature in their browsers. One of these events is before install prompt. Before actually that install banner is coming up, we have this event, which we can go ahead and defer. Let's say we can just say the event prevent default to just ignore what is its default, and then we can just assign this event to a variable in our, let's say, app component or in a services that we have in Angular. What it does is later, as you see in the screen, as soon as I open my application, I'm ready to show that banner, but I'm not showing that because I'm catching that event. And I'm going to show it later. For instance, it is good for my user that when they click on something or when they continue working and they are happy with my application, that time is a good time to show that banner to the user. So we easily can defer it, right? So if I have already this event stored in one of my variables, then I can check it out. And there is a prompt method on this event. If you just call it, then you can get that app banner. And based on your user choice, which is either, which is either dismissed or add to home screen, then you can do something. For instance, if they dismissed even after that deferred, then you can go ahead and send some analytics and then measure that, why your user just drop and don't add home screen, for your application. Let's talk about add theme. We all know that we have two events right now in the browser. Online, which is kind of a lie, and offline, which is definitely true. When we don't have Wi-Fi or connectivity, then offline is completely true. But when we are coming back online, that doesn't mean we necessarily are online. Maybe we have Wi-Fi, or the connection maybe is super slow. But that's good that we can actually define some method on these events and do our logic. For instance, let's look at here. I said, as you see in the demo, whenever my client or the device is going offline, I'm just changing slightly the theme. And I'm showing different style to my user, as well as some notification. Now they are aware that, OK, they are offline, although they can continue working, save the data, and do other stuff. And here is a very simple snippet that I've created with Angular material. So another thing that we can do is we can also go ahead and define two different styles, or as many styles as you want. We are not limited to just one style. And what does that mean? For instance, here I define two themes. I said I need black theme and light theme. And these are the codes for manipulating the DOM, and it's coming from Angular material. I'm going to change my app component class here. And then I'm setting two functions. I'm saying if it's night, just set the black theme, and if it's not dark or it's not night, just show the light theme. And how does that look? For instance, here I can say if the time is between like 8 or to 6 or different time, then you can just change your theme color completely. This is useful at the moment. Maybe it's not useful at the moment with this timing, but it's going to be useful when we have different APIs soon, like generic sensor APIs and ambient light APIs. They're going to help us to measure the light on the device, right, on our browsers. And that can be cool, right? So if we can detect the light of the device and we can show a proper UI to our user, that would be nice, a better user experience. Let's talk about background sync. So the story is that we have a website. OK, when we have connectivity, we can register our service worker. We can directly talk to our server or from service worker. There is no problem. But when we don't have a network or connectivity, then it's the time that we can leverage our browser's offline storage, such as, well, IndexedDB. So here is the time that you can actually store your data while your users are offline and register your background sync task or tag. So, and as soon as the connectivity is reestablished, then there is an event in service worker, which is sync event, that's going to be fired. Then you can listen to that and send your data from IndexedDB to the server. It's completely behind the scenes, right? Let's see in real code. Let's imagine that I am defining one task, which is sync node here. As you see here, first of all, I'm checking service worker, navigator, as well as sync manager, which is responsible for sync event task. But why I'm doing this? Because we are saying that we are progressively enhanced, right? And that means if some of our user doesn't have this feature, we don't have to affect them. We have to come up with other strategy for them as well. But if they have, then we can go ahead and register our tag as simple as this. You notice that I'm using one background sync variable here, which I'm going to tell you how we can share the code between service worker and our real application. So when connectivity reestablished, then that it is the time the sync event is going to be fired. Then you can go ahead and find the tag. You see that is the tag, background, the sync node, which I defined already. And I'm going to go ahead, and for instance, this is just an example. I go to my service worker, I go to my IndexedDB, read all of the data which they are not synced yet, and then I send the data to the server. All right, so there is a good function in Service Worker that you can import synchronously JavaScript into Service Worker. We all know that Service Worker is nothing rather than a JavaScript file, isn't it? So we can simply define our JavaScript files and share the code between our Service Worker and our application. So, and here is the way that you can import those data. Let's talk about offline storage. We have different possibilities. The first possibility is cache storage. I hope you have attended to, we had two talks about progressive web app in this conference, Simone and Eric today. I hope you have attended and you know something about Service Worker at least. But we have cache storage, which is a very good storage, and we can use it to store like simply request and respond. And also, we have IndexedDB, which is super underestimated, but it's a very powerful database in our browsers. The reason that it's super underestimated is because probably API is not so nice. You have to do a lot to achieve with IndexedDB. And probably because of some of the issue that you've seen about IndexedDB and the bugs in Safari, for instance. But at the moment, there is no issue. All the major browsers, they have a very good support of IndexedDB. However, I'm going to talk about PouchDB. PouchDB is a database based on CouchDB. And it is inspired by CouchDB. The underlying of this database is very good, and they are leveraging IndexedDB in our browser. So let's see how we can leverage and use PouchDB in Angular. Let's imagine that I have installed my package, and I'm defining my service to instantiate one copy of IndexedDB, which is easily, I can pass the name of my database to this constructor. So, and then I can also define my public method here, for instance, to save some notes in my application. And the case is, if you see in my demo here, although the client is offline, they can still work with application. You can save the state in IndexedDB, and then you can later sync back the data. So the goal is, instead of sending the data directly to the server, we can always, not always, let's say it depends on your strategy, you can save the data in IndexedDB as a middleware, and then you can sync back the data to server and from server. So you can achieve that with PouchDB as easy as you can kind of replicate from local to server or vice versa. And that means instead of just replicating like that, you can just call sync, and it's always going to be sync. So let's talk about cache strategy. When we are fetching data in our application, like fetching any assets or getting some data from server, when we are using fetching data, we have an event in service worker, which is fetch, that you can access, you can have access to request, and also you can go ahead and respond. Here is the time that you can define your strategy. The first strategy is cache only. And that means you can always respond from cache. What you can do here, you can just check if the request is already in your cache, and then you respond from cache. And that request never goes to server. This is a good example of this is to pre-cache your asset, and then you can always respond with those pre-cache assets, which makes your application fully offline. Network only. Well, sometimes in some use cases, you need fresh data. For instance, if you have like a website that needs to show stock, that definitely doesn't make sense to cache the data. So you need to check and respond always from network. We have cache first and then falling back to network. And that means as soon as I'm checking the request from cache, and if it's available, then I can respond. But if it's not available, I can fetch the request, put it to my cache in a dynamic, like maybe a storage name, like dynamic cache version. This is what we call it dynamic cache. So here's the story. In install event, you pre-cache some of the assets, which is critical for your application to be offline. And somehow you don't need some of other assets, and you can cache it on runtime, right? So here is that you can check and store the request to the cache. Another strategy is network first, falling back to cache. So if you want always a fresh data, as soon as the connectivity is there, then you can go ahead and check if you can get the response, and then just put it to the cache, update your cache, and if you're offline, then it doesn't matter. If you have it in your cache, you can match the request and show it to user. Cache with network update. You can go to cache, check the request. If it's available, that's fine, but you can, at the same time, go ahead and fetch the data and update your cache first, and then respond it. Another strategy is cache network race. Well, it seems a little bit silly. Well, cache is in my device, and definitely it's faster, right? But it turns out that it's not. Sometimes, in older device, reading and writing data from disk is slower than reading from network. Well, that is actually what I found. And here is that you can check both fetch and cache, and whichever is responding first, then you can just respond to your user. These strategies, like, you have to think about your application. Different part of your application could have different strategy. You don't have to just use one strategy for the whole application. That doesn't make sense at all. You need to think, okay, which part is important? Which part I need this strategy? Which part I need to use race strategy? And, all right, then what else you can do to improve user experience and give your user native app-like experience? There are a couple of APIs that I strongly suggest you go ahead and check it out. And I also strongly recommend you to implement on your application. So, because the usage is fairly easy, but the result is pretty good. The first API, Web Share API. Well, it's available on Android, that's fine. But it gives your user a very good experience about sharing. And It's like opening the share panel like an Android app to your user. Battery status. We can go ahead and do crazy stuff with battery. When battery is 5%, we can just show some messages, or you can just, if you have some background things to do on your application, you can just stop, when the battery is like less than 20%. You can save your user battery with less work, or whatever. Push notification. I'm sure that all of you are familiar with push notification. Payment request API. Vibration. That's good. I implemented this in one of my applications, and I also give my user an access to disable this if they don't want vibration. That is always good. Keep in mind that, okay, like in app theme, you are defining 2 different themes, right? Or any different kind of theme. But the time is, okay, it's 8. You want to change your app to dark. It's fine. But if some user doesn't like it, you have to give your user an option to revert it. And credential management. This is fairly new, but it gives a good ability to your user to kind of manage their password and sign up. And it's awesome. It means that through all the devices, they can easily sign in. It's kind of like a cloud saving password or similar to this, if you think of what is credential management. And all the code or the animation that you've seen is available in my GitHub. You can check it out. Also, the slide is available in my GitHub. You can just also check it out, which I've done it. And it works perfectly. And thank you so much. I'll be in the office hours. If you have any question, I'll be there.